Hello and welcome back to this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting and finishing the arithmetic section for Meet 4, so let's get right into it. So all of Arithmetic Meet 4 focuses on percents. So a percent is a number representing a fraction out of 100, and in percents we always say that 0% is the minimum. So we need to be able to convert percent into some other number that we can use in our calculations. Because you can't just straight up use, for example, 47% in calculations when you're calculating with percents. But if you convert a percent to decimals, then you can use them in your calculations a lot more easily. So here's how you convert percents to decimals. So 47% will be equal to 0.47. 8% is 0.08, and 62.5% is 0.625. And the reason why is because if we look at this definition, it says a number representing a fraction out of 100. So therefore, 47% should be 47 representing a fraction out of 100. So if we did 47 over 100, that would be the fraction that 47% represents. And then that would be equal to 0.47 if we actually divided it. Next, if we did 8%, that would represent 8 out of 100. And then that would be equal to 0.08 when we divided it. And same for 62.5%. It represents 62.5 out of 100. And when we divide that, that gets us 0.625. Now, a little bit more of an easy way of converting percents straight to decimals, and so you can skip this fraction step in the middle, is just figure out how many places the number needs to shift over in terms of place values. So you'll notice that when I have 47% here, that all the numbers in the decimals are 0, 4, and 7. When I have 8% here, the only number in the decimals besides the zeros is an 8. And when I have 62.5% here, in the decimal, all we have besides the zeros is a 6, 2, and 5. And that's because when we convert percents to decimals, really all we're doing is shifting the decimal place over. So here's the rule for converting them. If your percent is a 2-digit number, meaning that the highest part of that percent is in the tens place, for example, 47 has the 4 as its highest number in the tens place, and 62.5 has the 6 as its highest number in the tens place, then you do 0 point and then just write out your numbers. So 47 would be 0 point and then 47 because those are the digits in 47. If I had 78.41%, then since it starts with a number in the tens place, which is a 7, then I would just write 0 point and then write out all my numbers. 7, 8, 4, 1. And it's very simple. And then for 8%, since it doesn't have a number in the tens place, you can imagine it has a 0 here. And then if I were to write that out, it would not be 0.8. It would be 0 point, and then whatever's in the tens place, which is a 0, so 0.08. And this is a really important distinction to make because these two numbers represent completely different things. And then finally, sometimes you'll see this. If you have a number, or if you have a percent above 100, for example, 125%, you can still follow the same rules, where this digit, the one in the tens place, goes right after the decimal point. So you'd have a 2 and then a 5. But then this one would go before the decimal point. So it'd be 1.25. And again, that makes sense because that represents 125 out of 100. And if you divide this by 100, you get 1.25. So if you're ever unsure what decimal a percent would convert to, then if you're ever unsure using these rules, then you can always use the fractional step and just divide the percent number by 100. So most of the problems that you're going to deal with percents in Arithmetic Meet 4 are word problems. And there are a few key words and word problems that you need to know what it's asking you to do with that percent. So the first key word is of. So the word of means to find what value of the original number the percent is. So here I have an example which says, what is 20% of 150? And this is just a really basic example, but you're going to get bigger word problems that have the word of in it as well. So this means I need to find 20% of 150. Or if I find what it is in decimal form, 0.2 of 150. And it's really hard not to say the word of because this is the most commonly used word and it's hard to find a synonym for it. But basically what that means is I just multiply that percent converted to decimal, so 0.2 by 150. So by 150, and then if I multiplied 0.2 by 150, I would end up with 30. And again, for Meat 4, you get calculators, so you can just do this in your calculator. So any number or any percent of another number means you convert it to the decimal and then multiply that decimal by the number that you're finding the percent of. All right, so the next keyword then is larger than or more. So this means to add the percent of that number to the original number in the first place. So if I had a question saying, what is 20% more than 150? That's different than 20% of 150 because this one is saying, okay, find a fraction of the total 150. Whereas this one is saying, take 150 and then add 20%. So I would take 150 and then add 20% of 150, or in the calculations we did above, it'd be 0.2 times 150. And then if I did that out, it'd be 150 plus 30, and that would get me 180. So 180 is 20% more, or 20% larger than 150. And then the final keyword that you need to know is going to be off or less than. And we use the word less than most of the time, which means, well, it means less than, but the reason we would use the word off is if we're talking about some type of discount. So this means that the percent given is what is not included of the original number. It's kind of the opposite of the word of. So if I said, what is 20% less than 150, then what I would do is I say, okay, well, whatever number is 20% less of 150 or less than 150 is going to be a total of 80% of 150 because you're subtracting 20%. So if I take my original 100% and subtract 20% from it, that leaves me with 80% of the original number. And this is how you go about doing the less than problems. You subtract to find out what percent of the number you're going to have instead of what percent less than the number you're going to have. And then you just do what you do if you had a problem saying, what's 80% of 150? So I take 0.8, which is 80% in decimal form, and multiply it by 150. And in this case, that gets me 120. All right, so now I have a review question about using percents in word problems. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. All right, so the correct answer to this question was 81.90. So the question says the original price of a pair of jeans was $65. They are on sale at 40% off. Caroline buys 2 pairs. How much money does she need to pay in total if the sales tax is 5% after all discounts? So our first move with this problem should be to come up with an equation that represents this word problem. And that's what you should always do when you're encountered with word problems and you need to find a numerical answer. You should try to come up with some equation or convert everything in the word problem to numbers to represent the problem, and then just do that math out. So we know that the original price of a pair of jeans was 65% or $65. So that's $65. That was a bad 5. It looks like an S. Okay, $65. They're on sale for 40% off. So far we can't do anything. Because we don't know what's going on in the question. And then it says Caroline buys 2 pairs. Okay, so how much money does she need to pay in total if the sales tax is 5% after all discounts? So the real part of the question is how much money does she need to pay in total? And then the rest of this is information that we need to create the equation. So if it's asking us to find how much she pays in total, which I'm going to call T, as in the total amount, then first of all I can say, okay, well if she buys 2 pairs, we're going to multiply 2 by, and then the price of the jeans, which is $65. But wait, the jeans are 40% off. which means in order to find the price of each individual gene, I need to use my knowledge about the word off and find that 40% off means that they're going to be 60% of their original price. Because if you subtract that 40% from 100%, you get 60% left. So I'm actually going to cross this off and write 2 times and then 0.6 times, because 0.6 is 60% in decimal form. So 0.6 times 65. 65. So the total price is going to be 2 times 0.6, or 60% of $65. And then there's one more thing it says in the question: if the sales tax is 5% after all discounts. And for those of you who don't know what a sales tax is, it just means you're going to add that percent to the total. So it's going to be 5%. So after she takes all the discounts, your total percent will be, or your total amount will be 5% greater. And we know that with the word greater than, we take 1 or 1%, or like one whole of it, and then add that percent. So if I add 1 to 0.5, because 0.5 is 5% as a decimal, that will get me, I need to multiply by 1.05 to the total amount that we found before the sales tax. So here's my equation, and now you can just see it's a bunch of multiplication. Did I close all the parentheses? I didn't. Okay, there we go. So it's 1.05 times 2 times 0.6 times 65. And in this case, all you have to do is plug it into your calculator. I can't do this in my head. I would need a calculator for this too. But when you multiply these all out, so you multiply 0.6 times 65, then by 2, then by 1.05, you're going to end up with $81.90. All right, so next we need to talk about compounding. And you'll notice on this slide that even though it's called compounding, or the heading is compounding, the first thing I have a definition of is something called interest. And that's because the most common way that compounding is used is through something called compound interest. So it's really important that we know what interest is, because you'll see that word in a lot of problems as well, before we actually get to the more difficult stuff like compound interest. So interest is defined as an increase in something by a certain rate during a certain period of time, which sounds confusing at first, but here's an example below. So if a bank account offers 3% interest yearly, that means that they would increase whatever I put in the bank account originally by 3% every single year. So for example, if I put $100 in this bank account, after 1 year, that would become $103, because they're increasing that original $100 after 1 year, or every year, by 3%, which gets me to $103. And if you want to do the math out, then you take your original $100, and then you'd add 0.03, which is 3% in in decimal form, multiplied by 100. And that would get you 100 plus 3, and then that gets 103. Additionally, and this is really important when we get to compound interest, you could also write it as 100 multiplied by 1.03, where the 1 represents the 100%, and then the 0.3 represents the additional 3%. So in total, this represents 103%. And if you multiply something by 103%, it's going to increase by 3%. All right, so let's get into the two types of interest, because you might have noticed that I was being a little bit ambiguous about what happens if you have interest for multiple years. And that's because there are actually two different ways for that. So the first is called simple interest. So simple interest is the one that you're going to see less in questions. It's also the easier one. It's when the interest is based only on the original amount. So an example of this, and I'll go back to the $100, is if I put the $100 in the bank account, then after 1 year, that'd become $103. And that's pretty simple. That's the same between the two types of interest. But this is where it splits. With simple interest, instead of finding what an additional 3% is of this 103 that I ended up with after 1 year, so after 2 years, I would add another 3%, to the original $100. So I'd add another $3 and that gets me to 106. And then after 3 years, I add another $3 and that gets me to 109. So any money that you earn from interest doesn't get included with simple interest. So the really easy way to do simple interest then is, say I'm finding the simple interest, or how much money I make if I had simple interest, and a bank account offers 3% interest yearly. I put $100 in for 10 years. Then I say, okay, well, I'm adding 3% and then for 10 years. So that's going to be an additional 30%. And then if I found the answer to that, I'd say, okay, well, 30% greater than 100 is $130. So after 10 years with simple interest, I'd have $130 in the bank account. So that's a really, really simple interest. That's why it's called simple interest in the first place. You just take the original amount and only apply that interest to that original amount. Nothing that you make from interest gets interested again after each year. Now, the more difficult type of interest to deal with, especially in questions, and you probably guessed what it is by now, is what's called compound interest. And this is where compounding comes in. So that's when interest is always based off the total amount rather than the original amount. So if I had that $103, I would not just add another $3 if I was doing 3% interest yearly if it were compound interest. I would have to find 3% of this 103 and then add that. And then whatever I was left with, I would add 3% of that the next year and so on. So I actually have a review question, well, not a review question, a question here about compound interest. So it says, suppose you put $100 in the bank. At the end of each year, the bank adds 10% interest to your account balance. How much do you have in the bank at the end of 10 years? Okay, so if we were to solve this question with compound interest, it'd be a little bit more difficult. So the first year is pretty easy. I do $100, and that would become $110. Because if you're adding 10% interest, then you multiply by 1.1 or 110%. And if you multiply 100 by 1.1, that gets you 110. Okay, so the next year, instead of multiplying 100 by 1.1 and then adding that, you would actually multiply 110 by 1.1. So the next year it'd become, and I think it's going to be $121, which is different from simple interest because you'd only have $120 in simple interest. And then the next year, it's going to become something even more complicated, like $132.31, I believe. And then the next year is going to become even more complicated. And this is where you realize that simple or compound interest poses a problem. It's really hard just to do it in your head like it is with simple interest. And especially when you have a long amount of years, like 10 years, the decimal is going to get really, really long. So that's where we're going to learn how to simplify compound interest. All right, so I just wanted a little bit more room to explain this. So I have a separate slide with nothing on it yet. And we're going to look back at this question again and figure out how we can easily find the values of compound interest. So we're looking back at this problem that you put $100 in the bank, and at the end of each year, the bank adds 10% interest to your account balance. Then it asks, how much do you have in the bank at the end of 10 years? Well, we're going to actually create the equation that's used to find the answer using compound interest. So I start with $100 in the bank. So if I were just to compound for 1 year, find the interest for 1 year, then I would multiply by 1.1. So it'd just be 1.1 times 100. And that's really simple. That doesn't change from simple interest to compound interest. But that's where it gets a little bit more complicated. So when I multiply by 1.1, I end up with $110, right? So we're just gonna put this in parentheses and say, this is going to be equal to $110. And just keep that in mind. I'm going to erase this so I don't have as much written on the screen. All right, so the next year, you take that $110, which remember, this is equal to, and you multiply that $110 again by 1.1. So this is what it looks like after 2 years. You do 1.1 times that 1.1 times 100, which is $110. And then this is going to end up as $121, by the way. And so you can just imagine that this is going to evaluate to $121 after 2 years. All right, let me just erase this again. All right, so after the third year, you're going to multiply this 121, which this is equal to, by 1.1 again, because you're taking an additional 10%. And then this is where you should start noticing a pattern if you haven't noticed one already. Every single time that I compound, I just multiply by 1.1 again, right? So I multiply my original amount by 1.1, and then I multiply that by 1.1, and I multiply that by 1.1. And since the order that you do multiplication, if it's only multiplication, doesn't matter, I can simplify it to 1.1 times 1.1 times 1.1 for 3 years times 100. And you'll notice that the amount of times that I multiply by whatever my interest rate is, in this case, you're getting 110% each year, then that's the amount of times that I compound it. So I compound it 3 times because it's 3 years and I'm compounding every single year. So I multiply by 1.1 3 times then, and then multiply that by the amount. And this is where we can derive the formula from. So if this stays true, and by the way, it does with all compound interest scenarios, then I would take 1 plus whatever I'm adding. So if I was adding 10%, it'd be whatever 10% is in decimal form. So I'm going to put 10 over 100, and that will get me 1.1, right? So I'm taking 1 plus 10 over 100 in this case, and then I'm putting that to the third power because that means I'm multiplying it by itself 3 times if it's to the third power. So it's 1.1 times 1.1 times 1.1. That's what this means. And then you multiply that by the total amount that you enter in, or you deposit in a bank account, which is $100. So that's what this equation would represent in this scenario. But if we were to actually substitute variables in, right? So say I'm going to call the amount of money that I put in the account, I'm going to call it X. So X is how much money I put into the account, right? So I multiply X by 1 plus, and then whatever your percent is. So my percent, which I'm going to call I, or the interest rate. Actually, I'm going to call that R for rate over 100, right? Because that will get you to whatever number you're multiplying by. In this case, is 1.1. And then to the power of how many times it's compounded. So this one was compounded 3 times. That's why we have it to the power of 3. But if I were to do a variable to represent that, I would do t, or the amount of times it was compounded. So this is our formula in order to find compound interest. And I actually had it written down here. Final total equals X times 1 plus R over 100 to the power of t. So, and I'm just going to label this one more time. So you remember, t is the number of times. So number of times compounded. Sorry about my handwriting. It's hard to write with a mouse. And then R is your interest rate. So rate as in a percent. So if it's 3%, R would be 3. And X is how much you're deposited. So money deposited. All right, so now we can apply this equation to this question. So it says, how much do you have deposited, or how much do you have in the bank at the end of 10 years? So I'm just going to erase this here. And if we substitute our numbers into this equation, we can find the answer pretty readily. So we originally deposit $100 into the bank, that's X, and we multiply that by 1 plus 10 over 100, because R is 10. And I'm just going to write this as 1.1 because I've been saying that so much, so you probably know this is 1.1. And then to the power of how many times we compound. And since it compounds every year for 10 years, then the amount of times we compound is 10. And then this is where you definitely need the calculator. I can't do this in my head. So if you use a calculator, you do 1.1 to the power of 10. And it's really important that you don't multiply 100 by 1.1 first. You have to do this part first before you multiply this, just as a rule of order of operations. So if you do 1.1 to the power of 10, and then you multiply that by 100, then you're going to end up with your final answer. And I'm actually going to do that right now because I don't have the answer off the top of my head, like I said. Okay. So if I multiply 1.1, and I'm using a calculator right now, to the power of 10, so that gets me about 2.593. And at this point, you can just like round it if it tells you to round. So 2.593, and then multiply that by 100, and then that gets you $259.30 about. All right, and now finally, I have one more review question about compound interest. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was $2,201. So the question says Ivan deposited $2,000 in a bank account that compounds 0.4% monthly. How much can Ivan expect to earn in interest if he withdraws the money from the account 2 years after he initially deposited it? Round your answer to the nearest whole number of dollars. And I just realized that I actually wrote the answer incorrectly because it says how much can Ivan expect to earn? And so this is how much he'll have in his bank account. So if you're wondering, he can expect to earn $201 because it's 2,201 and he started with 2,000. Okay, so that's off the point. So let's figure out how to do this question. So this is a compound interest question. So let's write out our compound interest formula. So the total amount, so I'm going to write total, is going to be equal to the amount we deposit, which is X, multiplied by 1 plus, and then our interest rate, which is R over 100, and then to the power of how many times we compound, which is T. All right, and now if I substitute numbers in, we get our total is going to be 2,000, which is X, multiplied by 1 plus, and then our rate is 0.4, so it's going to be 0.4 over 100, and then to the power of T, or how many times we compound. And this one's a little bit more tricky with this question because it says it compounds every single month or monthly. And it says how much money can he expect to earn if he withdraws from the account 2 years after he initially deposited. So it says how many years it takes for him to withdraw, but it tells you it compounds monthly. So for this, we need to figure out how many months there are in 2 years. And since there are 12 months in 1 year, there are 24 months in 2 years. So after 2 years, if it compounds monthly, then he's going to compound 24 times. So we do to the power of 24. All right, so this is our total, 2,000 times 1 plus 0.4 over 100 to the power of 24. And then if we evaluate this out, we get our total to be 2,000 multiplied by 1.004 to the power of 24. And then remember, you have to do this part first before you multiply. So then you're going to get your total to be equal to 2,000 times roughly about 1.1, about 1.105. I think that's what it's going to be. I didn't actually do it out, but I'm guessing. And then when you multiply that out, that gets you $2,201. And if you didn't get exactly 2,201, that's actually right, but it says round your answer to the nearest whole number of dollars, which is why the final answer will be 2,201 after you round. All right, so just to review what we've learned this lesson. So we started with learning what percents are, which represent a fraction out of 100. And in order to convert them to decimals, you just divide that number by 100. And if you wanted to skip the fraction step, then you could just say whatever's in the tens place goes right after the decimal point. So for example, in this 62.5%, 6 is in the tens place. So the 6 goes in the right after the decimal point, and then all the digits actually stay the same. All right, and then we talked about interpreting percents in word problems, where we found that there are 3 key words that word problems use, which are of, larger than or more, and then off and less than. So of means that you just multiply the percent in decimal form by the original number. Larger than and more means you you find or you multiply the percent by, you multiply the percent in decimal form by the original number, and then add that to the original number because it's how much greater than it is. And then off is used in terms of discounts, but then the word less than means you find what percent of the number you actually have. So if it's 40% off, then you'd have 60% of a number, and then you find 60% of a number, or whatever percent of the number you have. Then for the review question, we found that Caroline would have to pay $81.90. And then finally, we talked about compounding, where we started with talking about interest, which is an increase in something by a certain rate during a certain period of time. So if a bank offered 3% interest yearly, they would increase how much you put into the account by 3% every year. And then there are two types of interest: simple and compound interest, where simple interest is only based off the original amount. So if you put $100 in, and then every year it would only add 3% of that original $100. Whereas compound interest is based off how much there's in at the account on any time, or sorry, how much there is in the account at any time. So if you had $103 after the first year, then you'd find 3% of that $103 and add that, and so on every single year. And then since compound interest was a little bit more difficult, we talked about how to find the formula for compound interest, which we derived to be X, which is the amount of money you put in, times 1 plus R over 100, where R is your rate as a percent, to the power of T. And T represents how many times something is compounded. And then finally, we did a review question where we found that Ivan would have $2,201 after 2 years after he initially deposited in a bank, or he would increase his amount by $201 total. All right, so that's all I have for today's lesson and Arithmetic Meet 4. I hope it was helpful, and I'll see you next time.